Hello, geometry kiddos, and welcome to today's lesson. Today we're doing chapter 6 and we're doing lesson 5. In this lesson, we're supposed to be talking about indirect proofs and inequalities in one triangle. We're going to save and talk about indirect proofs when I can have you guys back in the classroom. So we are going to get right into inequalities in one triangle. So let's look at this triangle that we have here, and we're just going to make some angle measurements in here, and you can tell that this is a right triangle, so this is 90 degrees. And you guys know that this side right here has a special name because it's a right triangle, and it's called the hypotenuse. And what do we know about the hypotenuse in a right triangle? The hypotenuse is always the what? It's always the longest side in a triangle. All right, so now let's just say that this one is a 30-degree angle and this is a 60-degree angle. So we looked at this 90-degree angle, and this side right here is the longest side. So now let's do just the opposite. And let's look at this side, and this is by far the shortest side. And if we look at the shortest side, look at the angle that is opposite of it. Look at this 30-degree angle. Well, the longest side was opposite of what? The largest angle. And if you look here, the shortest side is opposite of the smallest angle. And this side right here, if this one's the shortest and this one's the longest, that this one has to be the middle length side. And the middle length side is opposite of the middle degree. Is that coincidence, or does that always happen? And so that always happens in any kind of triangle that you have. Okay, so angle-side relationships in triangles. Okay, in any triangle, the largest angle is opposite of the longest side, and the smallest is opposite of the smallest. Always. So if you need to, take a moment, stop, pause this, and then get this information written down. All right, going on. Let's see, you're constructing a stage prop that shows a large triangle mountain. The bottom edge is about 32 feet. The left slope is about 24 feet, and the right slope is 26. List the angles J, K, L in order from smallest to largest. So smallest is your 24, and opposite of that, so angle L would be your smallest. And now let's go to the middle. The middle side is going to be your 26. So opposite of your middle is going to be angle J, thus leaving the biggest one to be angle K. All right, list the sides of the triangle in order from shortest to longest. Well, the first thing we're going to have to do is take 180 and subtract 51 and subtract 47 to get the measure of angle F. So 180 minus 51 minus 47 leaves us with 82. So this has to be an 82-degree angle. Okay, we want to pick the shortest. So the shortest is 47. So then the shortest side has to be the one opposite of that. So DF is going to be our shortest. Okay, then our middle angle is 51, and the side opposite of the middle is going to be EF, and then the longest is going to be our 82, and opposite of that is DE. All right, can any three segments always form a triangle? So if I gave you a 5-inch piece and a 6-inch piece and a 4-inch piece, 4, 5, and 6, would this eventually form some kind of triangle? So can we put any three segments together to always form a triangle? So you guys work on that. Think of a few, see if you can come up with a counterexample or anything like that. So what if I give you one side is 2 inches, another side is 3 inches, and another side is 8 inches? Will those three come together to form a triangle? A 2-inch piece, a 3-inch piece, and an 8-inch piece. So if we put 8 inches along the bottom, and I need a little bit of an angle in here, so if I make a 2-inch side right here, and if I make the 3-inch side right here, will they ever be able to come together? Well, if you think about it, that 2 inches is going to reach here, and that 3 inches is going to reach here. Are they ever going to be able to come together? Because that's only 5 inches. Isn't there 3 inches in the middle? So no, not any three segments can always form a triangle. What is the rule, or what has to happen in order for triangles to be made? So 4, 4, 7 can form a triangle, but 3, 3, 7 cannot. So what happens is the sum of two sides must be greater than third side. Okay, greater than, not greater than or equal to, because if we made this a 4, what would happen is it would reach 3 on one side and it would have 4 on the other, and it would make a straight line. There's no room for any kind of angle in there. So it has to actually be greater. The two sides have to always be greater than the third. So we can take 4 plus 4 is greater than 7. 7 plus 4 is greater than 4, and if we switch them, 4 plus 7, it's going to be a repeat, is also greater than 4. So all three of them work that the two sides is greater than the third side. Okay, so the sum of any two sides must be greater than the third side. Okay. If you need to, stop it, pause it, and then resume your video. All right, so 7 plus 10, is that greater than 19? 10 plus 19, is that greater than 7? 7 plus 19, is that greater than 10? And for all of these, they're yes, yes, yes. So yes, this will make a triangle. Okay, 2 plus 3, 2.3 plus 3.1, is that greater than 4.6? So what do we have, 5.4? So that works. Okay, 3.1 plus 4.6, is that greater? Yep. And 2.3, is that greater? Yes. So this is a triangle. Whoops, I think I made a mistake over here, didn't I? Let's go back to this first one. 7 plus 10 is 17. Is 17 greater than 19? And the answer is no. So this is not a triangle. This one does not work because 7 plus 10 is not greater than 19. All right, the lengths of two sides are 8 and 13. What could the possible third side be? So this is 8. This is 13. What could possibly be this side? What is the smallest? So there's a range, they say, of sides. So this is going to be between what two numbers could I have here? Okay, so I'm telling you the smallest one is 5 and 21. Not equal to 5, but bigger than 5. So like 5.1, 5.09, but it has to be bigger than 5 and less than 21. So where did I come up with those numbers? Well, if you take 8 plus 13, whoops, I transposed those numbers. 8 plus 13, we get 21. And if you take 13 minus 8, you get 5. And so that's where the two boundaries come from. All right, so if we have San Francisco and Oklahoma, this cannot be just any old number. It couldn't be just 500. Okay, so what could the distance between those two be? So it's going to be between two numbers, and what two numbers? So we're going to take 51 minus 46 and get 5. And we're going to take 51 plus 46 and get 97. So because this makes a triangle, it could be between 5 and 97 miles. All right, we're ready for homework time. So good luck on your homework for lesson 6-5.